Welcome to video 2 on independent and dependent probability, and where this video, our second video, is going to concentrate on dependent events. And in dependent events, it's just like it sounds. When something is dependent, that means it depends on something. And so that means that the probability of one event does affect the probability of another. The outcome of one does affect the other. So the second one is dependent on the first one. And if we were to have more than two, that means the probability of the third would be dependent on the second, and the fourth on the third, and the fifth on the fourth, and so on, depending on what's going on. And so to find that probability, you have to multiply. You multiply the probability of the first event times the probability of the second event after the first event occurs. And then if you have more, you would multiply the probability of the second event times the probability of the third event after the second event occurs. So let's just do that a couple times, and you're going to notice you really got to pay attention on what is going on. All right? So we're going to find the probability of dependent events. And it says in example 7, there are 2 white, 8 red, 5 blue marbles in a bag. Once selected, the marble is not replaced. Find the probability. So first of all, that's pretty key. Not replaced. Anytime something is not replaced, you automatically know it's dependent. Okay? And because I need to know the total number of possible outcomes, I got to count them up. 2 plus 8 plus 5, that's 15. And so here we go. The probability of 2 red. All right. So I know that when I look up here, there's 8 red. So there's 8 red out of the 15. That's the probability of pulling the first red marble. And I'm going to multiply that by the probability of the second one. Now we got to think for a second. If I've already taken a red out, there's not 8 red anymore, because I already took one out the first time. The probability of the second one is there's only 7. And then, well, I've already taken a marble out, so there's not 15 marbles anymore. There's only 14. Okay? And so there we have it, how the probability of one event affects the probability of the second. And now I can simplify. I can simplify going in right here. 2 goes into that 4 times. 2 goes into, let's do that a different way. 7 goes into 14, and then 2 goes into 8, 4. All right, there we go. And now we get 4 over 15. And when you divide 4 by 15, you get 26.7%. All right, let's go on to the next one and see what happens here. I'm going to go with blue. Probability of taking a red and then a blue. Well, once again, there's 8 red out of the 15, so that's the first one. And now we look at blue. Well, the first one we took out a red. We didn't take out a blue, so there's still 5 blue left. But we did take out a marble, so there's only 14. Okay, so notice how that changed a little bit. And now we can simplify here and go, well, 2 goes into there 4 times. 2 goes into here 7 times. 5 once, 5 3 times. We get 4 over 21. And again, if I say, hey, there's a 4/21st chance or probability of selecting a red and a blue, you're kind of like, huh? So then you want to do that math and you say it's 19%. Talking in percents is always better. Part C, blue and then red. So we look up there. Well, this time there's blue, and that is 5. And this time 5 is out of 15. Hey, notice blue and red, that's the opposite of red and blue. I wonder if we're going to get the same exact probability doing a different order. Well, maybe, maybe not. And so now we're going to red. Well, we know there's 8 left. We didn't take a red out the first time, so there's still 8 in there. But we did take out a marble, so there's only 14. And now I can simplify. Well, right here, 5 and 1 and 5 and 3. 8 here is 4, and down here is 7. And so we still get 4/21st, which we know is 19%. So it came out to be exactly the same on that one. Going to our last example, the probability of 2 white. That's the last example for this particular example. 2 white. Let's see, there are 2 white marbles. So the first probability is 2 out of 15. And then, well, I've already selected a white. So there's only 1 left, and I've taken a marble. There's only 14. I can do 1 simplifying right here. 2, 1, this goes 7. And this equals 1 out of 105, Well, we know that's going to be less than 1%, because 1 out of 100 would be 1%, and it's actually 0.9%. Just slightly less than 1% chance of getting both of the white marbles. Moving right along, you and a friend are playing a card game using a standard deck of 52 playing cards. The game begins by dealing 3 cards at a time to each player. What is the probability the first 3 cards are hearts? So if you understand a standard deck of 52 cards, there are 4 suits, there are hearts, there are diamonds, there are clubs, and there are spades, and there are 13 of each one of those. And 13 times 4 just happens to be 52. So we want to know, what is the probability the first 3 cards are hearts? Well, I just told you there's 13 of each. So when we start off, 13 out of the 52 cards are hearts. So the probability that the first card is a heart is 13 out of 52. I'm going to simplify that right away, and I'm going to say 1 out of 4. 1 out of 4 chance of the first card being a heart. Now we're going to the second one. Well, if we go to the second one, we've already gotten a heart. So there's not 13 left anymore, there's only 12. And there's not 52 anymore, there's only 51. And when we go to the third card, well, the first 2 were hearts, so now there's only 11 left. And we've taken 2 cards, so now there's only 50 cards left. Well, we can simplify a little bit here. I can go 2 into both of these. 2 goes into 12 6 times, 2 goes into 50, 25. So I'm going to come down here, and I'm going to say this is now 6 over 51. And times 11 over 25. And I recognize that 3 goes into 6 2 times, right here. And 3 goes into 51 17 times. Okay, 17. So now I'm going to multiply 1/4 times 2/17 times 11 over 25. And when I do that, I have 22 over, well, 4 times 17 times 25 happens to be 1,700. And when I divide 22 by 1,700, I get 1.3% chance. So yeah, you wouldn't understand it if I said, hey, you got a 22 out of 1,700% chance, well, or probability. 1.3% makes a lot more sense. So, ladies and gentlemen, our last example before our quick write, you have 10 coins in your pocket. 5 of them are quarters, 3 of them are dimes, and you have a nickel and a penny. Find the probability. So let's do the probability of 2 quarters. So I'm looking up there, and I have 5 quarters out of the 10 coins. So I'm going to go 5 over 10 times. Well, if I take 1 out, I only have 4 left, and I've taken 1, so now I have 9 coins. So 4 quarters out of 9 coins left on the second one. And of course, we can simplify here. This goes 1/2, and 2 goes into there 2 times. So that leaves us with 2/9, which is 22.2% chance. All right, going on to part B, nickel and a penny. So how many nickels do we have? Oh, we only have 1. So 1 nickel out of 10 multiplied by a penny. Oh, we have only 1 penny. And there's only 9 coins left because we already took the nickel out. So this is 1 out of 90. And 1 out of 90 is 1.1%. Going on to part C, 2 dimes and then a nickel. Ooh, we're going to take out 3 coins this time. 2 dimes and then a nickel. So how many dimes? There's 3 dimes. So my first pull is 3 out of the 10. And I've already taken a dime, so there's only 2 left. And I've already taken a coin, so there's only 9 coins left. And now I'm going on to a nickel. Well, there's 1 nickel, but there's only 8 coins left. Does that make sense? Outstanding. So I can simplify in a couple places. 3 goes into 9 3 times, and 2 goes into 10 5 times. And 1 times 1 times 1, that's 1 out of, and that's 1 out of 120. And 1 out of 120 is going to be less than 1%. In fact, it's 0.8%. All right? That's only with 10 coins. Less than 1% chance of getting those 3 coins in that order. And last one, penny, then a nickel, then a dime. Okay. Well, I'm going to grab a color here. Penny, there's 1 penny out of the 10 coins. And then nickel, well, there's 1 nickel, but now there's only 9 coins. And then we're going to a dime. Well, we haven't taken a dime out yet, so there's still 3 of those. But we have taken 2 coins out, so there's only 8 coins left. So we can simplify a little bit here. Oh, that's 3. And so now 1 and 1 and 1 is 1. And 10 times 3 times 8 is 240. And wow, that's a very slight chance of that one. And that's going to be less than 0.5%. In fact, it is 0.4% chance of selecting a penny, then a nickel, then a dime. All right? Hopefully your dependent probability makes a little bit of sense. If not, you are going to come to class with some questions. Your quick right is that you randomly pull 2 bills from your wallet. What is the probability that they are both 20? So when you look up here, I do have a 20, another 20, a 10, a 5, and a 1. So those are the bills in my wallet. What's the probability that you randomly select 2 20s from those bills in your pocket? Remember to come to class with questions. Oh my heavens. Questions are so important on probability of independent and dependent type. Yeah, go ahead and finish working on your 45 minutes of your assignment. Aggressiveness, urgency, use your time effectively, all those things that go to building not just your mind because it's math, but building your character in whatever you choose to do. All right, we'll see you tomorrow, people.